Yay! Hi, students. So I wanted to help a little bit with this evening, and so I wanted to go through a sample problem here and go over what that pink sheet really was trying to get you to do. So let's start with, I think I may have given the chocolate milk analogy to you. So if you have really chocolatey milk, you put the chocolate sauce in there, you mix it all up, and it's super chocolatey, and then you find out, oh no, there's no way you can drink that. How would you dilute that down to half the chocolatiness? Some students said I'd pour half of it down the sink and go add the same half. I would add regular milk so I could dilute the chocolate down. Some students said I would see the volume of the chocolate milk that they made. So say they made 2 cups of chocolate milk and they would add half the volume back in there. That's not quite right. You would actually add the full volume of milk, so double the milk. So your volume would go up, but your amount of chocolate would stay the same. But bottom line, that's too much estimate. So in science, we got to use something pretty precise. So we're going to use this M1V1, M2V2. The M in this case is going to be the concentration of salt in our water. On your worksheet, it said molarity, but there was also another version of this problem in your worksheet that said C1V1, C2V2, and that's probably better for us. It's concentration. So for us, our M or our C, depending upon how you want to look at it, is going to be the actually saltiness or solidity of the water. So saltiness, that would actually be an I, but we're going to use that for our M value. And then V will be the volume that we're looking for. So let's say everybody starts with water tomorrow that's ocean water. And ocean water is 35 PSU. We are going to use that to actually test or to create some lower concentrations of salt water. So let's just say you wanted to cut the amount of salt down to half. You wanted a 17.5 PSU water sample to see if your brine shrimp could handle being in that low of a salt water solution. So the way that we would figure this out is use that M1V1. So this is the original concentration of salt that we have, the big ocean water that's 35 PSU. And then we want to know how much of that do we actually need to use to create a 17.5 PSU solution. And let's say we need 40 milliliters of that. So 40 mLs of that at the outcome. So to create this thing, we're basically going to solve for the unknown. So we're going to solve for X here. So we've got 35 PSU times X equals 17.5 times 40. So let's go ahead and do the math. That is 700 PSU mLs. And that's not good enough. So we want to solve and get X all by itself over here. So let's divide this section by 35 PSU. And we can cross that whole thing off. We got to do the same thing on the left side as on the right-hand side. So we're going to divide by 35 PSU. And we can get rid of the units because they cancel out. But we're going to need to do the math. So we'll end up with X equals, and if you take 700 and divide it by 35, you end up with 20. And then the only units that are left are mLs, so that's 20 milliliters. So to make this work, you would start with your really salty water, and you would pour into your graduated cylinder, which kind of looks like that. You would pour in 20 milliliters of the really salty water of 35 PSU water, which is our ocean water. Pour in 20 milliliters in there. Okay, so we get it up to here. So that's 20 milliliters. And then you would add fresh water. So like the mountain runoff. Add fresh, non-salty water, fresh water, until you reach 40 milliliters, which was your original desired amount. So up, add until you get to 40 milliliters. So then you have your final product. Now this sounds awfully silly and simple and a lot of math to just say cut it in half and double the water. That is true. So let's actually look a little bit at a more particular problem. I do see that you know that your end amount was 40 milliliters, so you just poured in half and then cut it with half. That's okay. But let's try one more problem, please. Let's say you want to take, still have your 35 PSU salt water, because that's the only thing I'm going to give you tomorrow in class. And you want to test the brine shrimp and see if they can live in 30 PSU. So we start off with 35 PSU, and you need to know how much of this do you need to make a 30 PSU, and you want a sample that's 40 milliliters in volume, and this is what you want it to become. So again, this is going to be our X. You multiply 35 PSU by X equals, this is going to be 1,200, and that's, put those letters together, PSUMLs. Now you got to get rid of this stuff so we can get X all by itself. So divide by 35 PSU. Divide this side by 35 PSU. Cross it out, cross it out, cross it out. Do the division. 1,200 divided by 35 is 34.2. And the only units that are left are milliliters. And then bring down your X since he's the only one left over there. So that means if I want to make a sample of water that's still pretty close to salty ocean water, but not quite. It's not 35. It should only be 30 PSU. I'm going to take that graduated cylinder. Okay. I'm going to put 34.2 milliliters of the 35 PSU ocean water into the graduated cylinder. Then I want you to fill the rest of the way up with simple spring water, with just fresh water, until you hit, how big was our original sample that we wanted? We want a 40 milliliter sample, until you reach 40 milliliters. So your 34 goes up to here. You add approximately another 5.8 milliliters right up to here, and there is your 40 milliliters of 30 PSU. Okay, so tonight's homework, you have to kind of figure out what PSUs do you want to try your brine shrimp in, and that should be specifically based on the data from that USGS website that we looked at today. Thank you.